For this video, we will continue working in the Java-01-working with data repository that we have for the last couple of videos. If you need a refresher on how to retrieve that repository, I suggest going back to the printing data video in this series. But so far we've looked at printing data to the screen and storing data in variables and combining the two, printing the data in those variables. And so in this video, we're going to look at manipulating the data in those variables. So the idea here is that, it's all fine to take a piece of data, store it in a variable, print that variable, but it's not necessarily interesting unless you can perform some kind of operation on that data. And really, at the core of programming is you're trying to store data and manipulate data so that it can perform some task for you in some way, shape, form, or fashion. And so that's kind of the goal we're going to be looking at in this video. And so that's where we'll pick up with this. It's important to keep in mind that different types of data have different actions you can perform on them. So the things you can do to an integer aren't necessarily going to be the same kinds of things you can do to a Boolean or to a string. And so we're going to start by looking at what can we do with integer types. And we're going to say that we're looking at what are called integer operators. And so the operators are the special components of the Java language that let us perform an operation on the data. So I'm going to start with a simple variable, an int called number, whose value is 0. And just for consistency, we're going to print out that value. So I set number equal to 0, and I'm going to print it. When I run the program, there's that 0. But now let's say I want to do something to it. Let's say that I want to use 1 instead. We'll run that, and we get 1 there. There is an operator that is called the unary negation operator. When you see unary, that tells you one thing. So some operators take one value or one variable, and some operators will take 2 variables. So for a unary operator, we're only going to have one variable, and we're going to use the number variable for that. For negation, that tells you that it's going to make it the opposite of whatever it is. So it would turn a positive number negative or a negative number positive. And the way we can do that is we can say number gets negative number. And this is where programming and mathematics start to look a little bit different. In math, this is a weird thing to say unless the number is 0. This says, oh, the number is equal to itself but negative. But remember, in programming, when we see a single equal sign like that, we want to read it as number gets the negated number. So what that means is hey, we're going to look in the number. We're going to take whatever's in there right now. We're going to make it negative, and then we're going to put it back in there. So that when I run my print again, we see 1, and then we see negative 1. Because up here, first we print the value, then we change the value, and then we make the value print it again. And so that's why we see the 1 and the negative 1. So that's our first operator for numbers, is the unary negation operator. That's probably the most common unary operator you'll see with integer types. Most of the other operators you see will be binary types. And so what we'll do is we'll just create 2 simple variables here. We'll call it A, and we'll call the other one B. So we've created variables A and B, have values of 3 and 5, and we're going to start looking at some other operators. So the first operator we're going to look at is the addition operator. And addition is a binary operator. And when you add two numbers together, you get a sum. And in Java, the addition operator is just the plus sign. So when we want to add two numbers together, we can do it like that and say we're going to print the sum. Now, one quick note here is I could just skip the variable here and just say, oh, I just want to print what a plus b is. And if you look, a is 3, b is 5. So if you add those together, you should get 8. And that's the output we get here. But if we did want to use a variable to store that value, we would do that here, and we can run the program exactly the same. So that is the first binary operator. The second binary operator is for subtraction. And so in this case, when you subtract two numbers, you get a difference. But there are two different differences we could look at. Because a minus b will give us a difference, and b minus a will also give us a difference. We could have written the sum as being a plus b or b plus a, and that's because addition is commutative, so the order you add them in doesn't matter, but the order you subtract in does matter. So if we were to print both of these, we have difference 1 and difference 2, and we were to run this program, we get -2 and we get +2. That's because difference 1 is a minus b. 3 minus 5 gives us a negative number. The second difference is b minus a. 5 minus 3 gives us a positive number. So that's another operator we have, and it's also a binary operator. The next operator that we'll look at is the multiplication operator, which, as you might guess, is also a binary operator. And like the addition operator, when we find a product, we could do a times b, or we could do b times a. Just like addition, multiplication is commutative, so the order doesn't matter. So when I run this to print what the product is, print line product, we should get a times b, which is 3 times 5, and we get 15. So those are three of the most common binary operators we'll see with numbers. And one thing that we should note is that these operators work with integers a and b, but they also work with doubles a and b. So if I were to find the sum as being a plus b, I can't say that the sum is an int anymore. Now I need a double sum is a plus b, because a and b are doubles, so the sum needs to also be a double. So system.out.println the sum. When I run this, I'm going to get a decimal number, because now the sum is going to be a decimal number. Likewise, I can find my differences. I'm going to copy these two lines. We'll clear that out. And instead of being ints, again, these are both going to be doubles. Double, double. And when I run this, I can do system.out.println difference 1, and I can run difference 2. So when I run this, I should get two decimal numbers, and here you'll notice something weird. If you look at these two numbers, they are exactly 0.6 apart. But when we run the math, we get 0.6 and then a bunch of zeros and then a 1. And this goes back to something we talked about in an earlier video about how the double can't perfectly represent some numbers. you'll see that it's pretty close, but because there is some what we say uncertainty, some approximation in how these numbers are stored, you do get this little bit of we call it rounding error, precision error, garbage is what you'll hear sometimes, but you'll get these slight differences. And so that's going to be very important when we start getting into conditionals in a later talk. But just kind of keep that in mind with doubles, is that while the values are going to be pretty close to what you expect, there is always going to be some slight difference for many, many numbers. And so because of that, you have to be very careful with how you use these. Now, in most cases, it doesn't cause any problems, but when it does cause problems, we'll address that and see where that happens. So that's how you can use doubles in subtraction. And again, you can also use doubles in multiplication. A times B, and then we will do system.out.println product. And we run this, we get the same thing here. So again, the addition, subtraction, multiplication operators all work exactly the same as you would expect with both integers and doubles. And then also keep in mind that the unary operator will also work. So if our double is a number and it's 0.5 and we want to set the number equal to the negative of the number, and we want to run system.out.println with the number before and after we make that assignment, and we can see that it also works the same. So these are 4 operations that work basically how you'd expect: the unary negation, the binary addition, the binary subtraction, the binary multiplication. One more thing to be aware of is that you can actually do some combined operations here. What I mean by that is if I want to find the sum and I want to add my integer to my real number, it doesn't like that. But if I change the type to a double, all of a sudden it does. And what that means to you is that it is okay to combine integers and real numbers, ints and doubles, with addition, subtraction, multiplication in some ways sometimes. In this case, I'm combining an integer and a real number. A real number has more information than an integer does because it holds that decimal place. So because of that, you can combine an integer and a real number through one of these operators and stick the value into a double variable. But you can't stick them into an int variable because a double has more information. So there are ways around this, but just know that when we do this, we're doing something called coercion, where we are actually taking the value of the integer, treating it as a double, combining it with the real number, and putting it in a new variable that is also a double. And so that basically means we are treating one type as another implicitly. And that means we're not telling it, hey, treat this integer as a double. We are just letting Java do that kind of on its own. So be aware that sometimes you can very easily combine integers and real numbers without Java having an issue with it. Sometimes you can't. And so in those cases, you'll want to be aware. But those are some of the operators, and these are, we'll say, are the operators that kind of behave as you would expect because they are more or less the same as you encounter in mathematics. And so if I were to try to do my system.out.println on this sum, 5 plus 2.1 is 7.1, and it's a double, so that's what I would expect to see. And I do see that. So it did treat that, that integer as that. Now, if I try to do something like this, it doesn't like that because we know 5.0 is a double, but we said it's going to be an int. So this is a kind of a good time to kind of play around and see what works and what doesn't work, and you can kind of intuit some of these rules yourself. Again, a good rule of thumb is if it's an integer, treat it like an integer, put it in an int. If it's a real number, treat it like a real number, put it in a double. If you're combining integers with real numbers, your result is going to be a real number, is going to be a double. You should not expect to get an integer. But that more or less covers the basic operations that behave exactly as we expect them to. The next thing we're going to talk about is what are some operations that maybe don't behave like we expect. The next set of operations we're going to look at all relate to the idea of division. So, and you might have noticed that we left division out of what you might have expected as the typical operations. Addition, multiplication, subtraction, and division are normally what you would expect next. But in Java, there are actually a few different types of division. The first type we're going to talk about is integer division. And integer division, as you might expect, works with integers. So if I have integer a equals 10 and integer b equals 5, then I can say that the quotient is just a divided by b, and I can do system.out.println quotient. And so in this case, we know that the 10 divided by 5 is 2, so this should print 2. And we run it, that's what we get. But what you might not expect, and again, we can take this a little bit further. We can say, okay, well, what if this is 15? Well, 15 divided by 5 is 3. We get 3. What if this is 0? 0 divided by 5 is 0. We get 0. No problem there. But where it becomes maybe a little odd is in a case like 11. When you divide 11 by 5, you get approximately, well, exactly 2.2, or 2 1/5, or 2 remainder 1. Not a nice answer. But because we are working with integers, 11 is an integer type, 5 is an integer type, and we are performing division on them, integer division is what happens when you divide two integers. And what it does is it calculates the quotient and totally ignores the remainder. So 11 divided by 5 has a quotient of 2 and a remainder of 1, and so the answer is 2. It totally ignores the remainder. So if a is 10, you get 2. If a is 11, you get 2. All the way up to 14 divided by 5, you still get 2. And that's because 5 doesn't go into 14 evenly. It's going to leave a remainder. And when you do integer division, the remainder gets ignored. And this is the type of division that happens with two integers. So if you do any kind of division with two integers, that's what you're going to get. Now, because we have this case where, just like subtraction, the order matters, we can look at, well, what if I do the other quotient, quotient 2, where we do b divided by a? Well, now we're asking, how many times does 14 go into 5? Well, it goes 0 times with a remainder of 5. So when I get quotient 2, I'm actually going to get 0, because when we say how many times does 14 go into 5, the quotient is 0 and the remainder is 5. And because this is integer division, the remainder gets ignored, and then the result is only the quotient. And so that's integer division, and that's something to kind of be aware of, that when you try to divide integers, it may not behave exactly as you expect. The second type of division we'll call real division. And real division happens with at least one real number. So if you have two real numbers, two doubles, or one real number and one integer, one double and one int, you're going to get real division. And real division works as you would expect. So let's say that we have double A equals 14.0, double B equals 5.0, and I'll change A back to 10 actually, because that's what we did in the first example. And we'll say, okay, double quotient 1 is A divided by B, double quotient 2 is B divided by A, and we'll just do system.out.println quotient 1 and system.out.println quotient 2. So when we print these, we'll get actually different results. So A divided by B, 10 divided by 5 is 2, but it's a double, so it's 2.0. When we do B minus A, well, 5 divided by 10 is 1/2, and as a decimal, because it's a double, is 0.5. And so this kind of works as your calculator would do division, if you want to think about it like that. Whereas integer division is really behaving very similarly to how you would have learned like long division in elementary school or middle school, depending on when you learned division. And so that's a difference here, is that the real division behaves as you would expect. The integer division maybe is a little bit less intuitive, but if you think back to when you first learned division, it makes a lot more sense. And if you change these numbers around, you'll get different results. And this is where you start getting these more random number strings that you see. But again, it behaves exactly as regular division on your calculator does. And so that's something to be aware of. So one thing to also note here is that if you have a double and an int, you can find, okay, well, quotient 1 is A divided by B, and quotient 2 is B divided by A. And we'll just run those print statements again here. So before we said if you have two integers, two ints, you get integer division. But real division happens with at least one real. And so we should get real division happening here. So for quotient 1, A divided by B, 10 divided by 2, 5.0. Quotient 2, B divided by A, 2 divided by 10 is 0.2, and that's what we get here. So if we change them to the values we were working with up here, 14 and 5, and we were to run that, we get more exact divisions. And if I were to switch which one's the int and which one's the double, and just make them happy by getting rid there and there, right? Notice I get the same answers on both cases. So this is something important that's important to note with division, is that if you are dividing two integers, you are going to ignore the remainder and get a quotient, because integer division must produce an integer. And so because of that, it has to ignore the remainder. Same for real division. Real division must produce a real number, so it doesn't have to ignore the remainder. Now, I mentioned there are actually three types of division. We have integer division, real division, and lastly, we have what's called modulus or modulo division. And modulo division you can think of as going hand in hand with integer division. So if you have two numbers, let's say A is 14 and B is 5, you can say, okay, well, I want to know what the quotient is, and the quotient is A divided by B, and you can say system.out.println quotient, and you can get that integer division. How many times does 5 go into 14? Oh, it goes 2 times. But you are also able to find the remainder, and you find the remainder with the percent sign. And this is what's called the modulus division or the modulo division. So whereas integer division took two integers and found the quotient, the modulus division is going to take two integers in this case and find the remainder. So using integer division and modulus division, you can build up toward kind of what you would find as a real division answer, because if you have both the quotient and the remainder, you can kind of figure out what is the exact division here. So we know 14 divided by 5 has a remainder, has a quotient of 2, but 5 times 2 is 10. So 14 minus 10 should be 4. So 5 goes into 14 two times with 4 left over. So if we run this, we find, okay, the quotient is 2 and the remainder is 4. And so that's our third type of division. So we have real division, which works as we expect. We have integer division, which will only give us the quotient and happens anytime we're working with two integers. And then we have the modulus or modulo division, which uses a different symbol and will give us the remainder. Now, one thing to be aware of is I could try to use doubles here, but notice that the types are not happy so far. I got to change everything to doubles. And it would actually work just fine. So if I run that, I still get an answer here. So you can use modulus or modulo division. It works with integers or with real numbers or a combination. So if I run that, I still get the same answer. And what's important to know here is that this is very much a just because you can doesn't mean you should situation. While you can do modulus division with doubles, that is not the way you will most often see it. In most cases, you will only see modulus division with integer types. But again, that doesn't mean you can't do it with double types. It's just a situation of, don't do it unless you have a reason to do it. In almost every case, you will only be interested in this with integers. And so that kind of rounds out the very basic mathematical operations that you can do when operating on data. But there's actually more you can do with these same operations just over and over. And so that's kind of the next thing we're going to look at with these numbers. Now that we have some basic operations, we can actually do a lot more with them. So I'll say that I have my number, which will be 5, and I want to run system.out.println number. And when I run that, I should just get 5, so that's all well and good, just like I would expect. And now let's say I want a new number. My new number is equal to my old number plus 2. System.out.println new number. And I run that. My number is 5, then I add 2 to it and I get a new number, that's 7. And so that's kind of what we would expect to see based on how we've been looking at our numbers so far. But maybe I don't want a new variable. Maybe I actually want to change my number by 2 and leave it as it is. Maybe I thought it was 5 and it's gone up by 2 and it's going to need to stay that way until I change it again. And so there's a way we can do that. The most clear way is by using our assignment operators, right? So I can say number gets the old value of number plus 2. And then I can print it again. And when I run that, I can see, okay, the value of number changed. Because what this line says is take the value in number, add 2 to it, and put that value back where you found it. But that's not the only way to write this. The more common way you'll see this is by doing a combination operator, just like this. So looking at line 179 and 180, these two lines say the exact same thing. This line says start with number, add 2 to it, put it back. This line is doing it kind of in a more condensed fashion, but it's saying, hey, take the value in number, and when you get it, do this to it, add 2 to it, and put it right back where you found it. So that when I run it again, I still get 7. So these are 2 ways of doing the exact same thing. Number equal number plus 2, and number plus equal 2. This is the more common way that you will see it. But it also works with doubling or multiplying. So I can say number equals number times 10. So I started with 5, I multiply it by 10, that's going to give me 50, just like we would expect right there. But just like I could with addition, I can say, okay, well, let's just do that in one symbol here. Take the value in number, multiply it by 10, and then reassign it to number. And so I, again, will get 5 and 50 before I change it. And so again, as a reminder, remember, commenting out these lines means that they don't get executed, so they'll stay in there. But it's not just multiplication and addition. I can do the same thing with subtraction. When I run this, I want to get 5 and 2 because in line 186, I subtracted 3. But again, that's not the only way to do it. I could do number minus equal 3 and get the same answer. But really, if you think about it, I could also say, well, what if I did number equal plus equal negative 3? These 2 lines are effectively saying the same thing. This line says subtract positive 3. This line says add negative 3, but mathematically, those are the same thing. So understanding how your mathematical operations work will make some of these things in programming, and in Java specifically, make a little bit more sense to you. So we've seen addition, multiplication, subtraction. We can also do the same thing with our division operator. But again, keep in mind we're using integer division because we are working with integers. So this isn't going to do real division. It's going to only give us the quotient. It'll reassign the quotient. So 5 divided by 2 is 2 with a remainder of 1. So the quotient is 2. So when I print, the number I should get is 2. So 5 is the number I started with. When I do integer division and get the 2, that's what I get. But the same combine operator works the same here too. And on mine, you might notice this combine symbol. Yours probably won't look like this. Let me turn my ligatures off so that we don't see them. And now it will look more like this in yours. But again, that does the exact same behavior. And so these are some of our combine assignment operators. And one more we can do, as you might expect, if you can do it with the integer division, why can't you do it with the modulus division? Right? So now we're going to get the, instead of reassigning the quotient, we're going to reassign the remainder. So again, our number is 5. 5 divided by 2 gives us a remainder of 1. So now the number goes from 5 to 1. And just like with all the other operators, we have the nice simple remainder equal or modulus equal, and we'll get the same result. So those are most of the common assignment operators you'll see. I do want to go back to this briefly with the addition. There's actually a special case where you only want to add 1. And when you do that, there's a lot of different ways you can do it. But instead, you can say number equal. Rather, you don't even have to have it equal. You just say number plus plus. And what that does is it adds 1. You cannot add any other number this way. It'll be exactly 1. So it starts as 5. Now it should be 6. and it is 6. But you can also do the plus plus number. So the plus plus can come before or after the variable, and it changes by 1 either way. Now, there are subtle differences here that we're not going to talk about right now that we might address later, but just know that these two actions give you the same result, but behave a little bit differently. And it will do so without an assignment operator. So doing this actually changes the value. And as you might expect, we do adding 1 a lot, so it has its own special symbol. We also can subtract 1 in the exact same way. So number minus minus will subtract 1, again, without an assignment operator. So if we run that, we started at 5, now it's 4. And just like with addition, we can do the same thing. We can do them before or after, and we get the same answer. One thing that we'll want to note is what these are called. These are called up here, these are the increment operators. And when the symbols are after, this is called postfix. And when they're before, they're called prefix. So just like here, when they're before, it's prefix. And when they're after, it's postfix. But these aren't the increment operators. These are the decrement operators. And so these are just very special ways to add and subtract 1. If you just want to add and subtract 1, you could use the addition operator. You could use the combine addition assignment operator, or you could use the postfix increment or the prefix increment. All of them can be used to add 1, and then all of your subtraction and decrement operators can be used to subtract 1. There are a variety of ways to add and subtract 1. In fact, you can use the addition operator to subtract 1 if you are clever with your signs, and you can use the subtraction operator to add 1, again, if you're clever with your signs. So these are kind of your assignment operators that you can work with and your ways to quickly change a value in a number. And a lot of these work with integers or doubles. In fact, if we were to change number to be a double, we can see pretty quickly which ones work. So the assign and add works. The add assignment together works. The prefix and postfix increment operators both seem to work. The multiplying operators work. The subtraction operators work. So far it looks like just about everything is going to work with the doubles or with the integers, which is a handy thing to note. One thing to be aware of is in this case where we're reassigning the quotient. That is only for integer variables. If you're dealing with real number variables, it will perform regular division. So if I were to run this, we'll move that down a little bit. If I were to run just the simple division, noting that number is a double right now, I do get 2.5. But if I were to change it back to an int, I get 2. So just like we saw before, the division symbol does act differently depending on what type of data it works with. And it might be confusing here because you're saying, oh, well, the only number in here, that's an integer. 2 is an integer. And you're right. But number, when you use a double here, number is itself a real number variable, a double. And so because of that, this division says, okay, I've got a double and I've got an int. Well, that means I need to do real division because real division happens when you have at least one real number. So this is something good to kind of practice with and see what behaves like you expect, what doesn't behave like you expect. That way you can develop an intuition for it and get some feel for it. But those are probably the most common numerical operators. And there are some other actions you can take on numbers that aren't operators that we'll also look at. So having seen addition, multiplication, subtraction, and now 3 different kinds of division, as well as ways to change values of variables with those, there are some other more complicated functions that you see in mathematics sometimes. And so the ones we're going to look at now, we can use with doubles or integers, and we should usually get doubles back. We'll see when that's not the case, but we'll just start with a value. We'll say double x equals 10.0 because that's a simple one we want to go with. I can find a new value of x using some math functions. So to advance these, to get to these functions, we're going to go math dot, and we'll say SQRT is an interesting one. SQRT is a Java function that gives us the square root, and you can hover over and read all this about it. And if I want to print that, I can do system.out.println value, and this should give me the square root of 10, which should be a little bit more than 3. If I run that, that's exactly what I get. Now, one thing to note about the square root is you can't take the square root of a negative number. So if I use a negative here, there's no problem so far. But if I try to run the program now, I get this thing called nan. And nan just means not a number. So the square root function will give nan for negative numbers. So that's something important to note. Another interesting function that might be useful is the math.abs function. And abs is the function for absolute value. So if I run that, the absolute value of negative 10 is just positive 10. Now if I were to change this to be an int, I can see here that this will actually give me an int back. So some of the functions will give you back the type that you give it. Other types will just give you back the value in the same format. Well, rather, will always give you a double, I should say. So for example, here, if I look here, the square root is always going to give me a double, even though I'm giving it negative 10, just because the square root of an integer being an integer isn't a guarantee, and it doesn't always make sense. But that's just another thing to be aware of. So some of these can give you ints, some of them can give you doubles, some of them will change depending on what you get. We'll leave that as a double. There are also some other functions like the trigonometric functions. So double value equals math dot, let's say we want sine of x. If I run that, then I get a value here. One thing to be aware of with your trig functions is that the value you give it is expected in radians. So this isn't negative 10 degrees, this is negative 10 radians. Maybe I wanted to know what it is for pi. So I could do 3.14 radians. I know that the sine of pi radians should be 0. And it doesn't give me exactly 0, but that makes sense because I didn't give it exactly pi. But Java does have a way to get pi, and that's with using math.pi. If I run that, now I get, this number is still not quite 0, but notice this e to the negative 16 means it's a 0 point, and then about 15 decimals, and then the 1. So this is a very, very, very small number that is, for all practical purposes, 0. And this is just another case of looking at that double having to do some approximation. And so there are a lot of functions in the math library that are definitely worth playing with. But one thing I do want to point out is that we didn't have to actually capture these in a separate value. So if I run system.out.println x and print the value of x, what I had been doing was capturing a value into a variable and then printing that value. And we get all that. And what's interesting to note is I don't have to do that. I can take the piece of the operation. Notice I'm leaving off the semicolon because I don't want the whole statement. I just want the part of it that does something. And I can put that in here. I get no squiggles, and I run it, and I get that. So this is a case of using the function directly. And if you play with this and get kind of uncomfortable with this notation of doing things, that's okay. You don't have to do it like this. And it's something we'll address further when we get into working with functions as more than we have been. But these are nice because these are mathematical functions that Java in the language library have available for you. And there's a whole bunch in here. So you can access them pretty easily to see what they are by running just math dot in VS Code. And you can scroll through and just see what all the different ones are. If you hover over one, you can click on one and you can just read a little bit of it. You might have to add some parentheses on there, but when you do, you can read what they're about. So this is also something worth exploring and spending some time on. So I recommend reading through and seeing what you can find because there's a lot of functions in here. Probably the last one we'll talk about that you'll use a lot is the POW function. So we'll say double A is 3, we'll say double B is 2, and we'll throw on some 0.0 so we don't forget. And the power answer is going to be math.powab. And pow is a pretty useful function because what it does is it takes the first number, A, and raises it to the second number's power. So in this case, A has a value of 3, B has a value of 2, so this is saying what is 3 to the second power, or what is 3 squared? And I should get 9, and I do. And if I flip the order to go, instead of AB, go BA, that's saying what's 2 to the third power? Well, that's 8. And maybe I'm interested in what is, let's say, power equal math.pow. What is 2 to the 0.5 power? And that gives me 1.414 ... But what we might be interested to learn is that if I run system.out.println math.square root of 2, I get the same answer. And so POW is useful because it lets you raise numbers to powers, and that includes positive powers, negative powers, fractional powers. And so that really gives you access to all of the different things you can do with an exponent in mathematics. So while the math square root function is very optimized and very good at finding the square root, it can only find the square root. So if you need something a little more versatile, the POW function is there for you. So these are some more functions you can use in Java working with your numbers. And remember, these all work the same with doubles, and you might see some slightly different behavior with integers. So that's something to kind of play with and get a feel for yourself. But that should give you a lot of options in your toolkit for working with numbers.